Hi, in this video, we want to take a look at using raster maps in ggplot. So when I say raster, that is a data storage format for an image that we want to use as a map. Now, how this is different from an image is that it's also connected to a coordinate system. All right, so like I could go up into the air in a plane, take a picture, and I could use that picture as a map very effectively for a lot of purposes. This is very common in skydiving. If you go to most drop zones, they have images of their drop zone so that you can look and you can see like where you want to land, where you don't want to land, where to go if you land off, stuff like that. Well, in data science, that's not really good enough for most purposes because we want to invoke things like our coordinates, our latitude and our longitude. So raster data storage format connects that image to latitude and longitude. Okay. Now, the examples I'm going to go through are taken from Hadley Wickham's book and his GitHub. So ggplot2, elegant graphics for data analysis. Here's the GitHub page to get this. And if you read through the text that I have in this video, all the references, whenever there's an I, that's Hadley referring to himself, and the references to other parts of books or websites, that is within his book. Okay, so a raster map is an image connected to latitude and longitude. Frequently, these will be stored in TIFF file formats. All right, and there's several ways to pull these into R. The ones that we're going to use here, we're going to use stars package, and we're also going to use, let's see, I have to look real quick, I'm cheating. We're going to use ggmap to handle how we're going to tackle this. All right, so when we load this data set, the image and the information about its coordinates are already in there for us, very nicely for us. All right, so let's start working with a raster map of Michigan. So first thing I'm going to do, I'm going to load the data. Now this data set comes from Hadley's webpage, his GitHub, and he calls it miraster.rds. Now, something I want to point out is if you're actually working through his GitHub and you're working through his textbook, I wasn't able to get everything going on my personal machine. I don't know what the problem was. I was unable to successfully load the data, and for some of the data that is in the GitHub page, and then use the stars package to get things going. So I'm only displaying what worked out. All right, so Hadley has Michigan raster data set, and it's an RDS file, so I use read RDS, which is in base R. And now what I'm going to do, I'm going to use the Magrittr package to do some piping. So I'm going to take the map data. I'm going to tell it to grab the counties of Michigan. I'm going to select latitude, longitude, group, and ID. All right, so here, this gives me the latitude and longitude of county boundaries. Here, I'm going to get a bounding box around the areas I actually want for the raster. So here, I want to only plot the region of this image that connects to the data that I'm actually interested in. And to do that, I'm going to get a bounding box using the Michigan counties data set that we have right here. I could have also typed it in manually if I want to, or pull it in another way. All right, so let's go ahead and just do a quick raster map with ggmap. So I'm using the ggmap package and its namesake function, and I just pass in my raster straight in, easy peasy lemon squeezy. And we can see, boom, we have a map of Michigan. All right, so now this is an image, and you'll notice that we have X and Y coordinates corresponding to longitude and latitude. All right, well, let's see if we can do a little bit more with this. All right, well, in data science, we like to put things on top of our maps just so that we have more to read, more to look at, more to interpret. So let's go ahead and do that. Let's go ahead and put cities onto there. All right, so I'm going to go ahead and get ggplot going. And I'm going to, from ggplot, from maps, I'm going to grab the US cities data set. I'm going to make it into a table. I'm going to restrict it to just Michigan. And then I'm going to get, I'm going to get rid of some stuff I don't need, and I'm going to convert the name of longitude to lawn, because that's just consistent with what I've got going on elsewhere. And I'm going to organize the data by population. Now, what I want to do is I use ggmap to plot just like I did before, but this time I'm going to put a point for each of the major cities. All right, so I'm going to have the size correspond to the population. The size of the dot corresponds to the population. Here's the data set I'm using. I'm going to have every color, every point will be colored red, and I'm going to scale the dots by area. And so now it's very easy to see where are the major populated areas of Michigan. All right, so now that one was an image, and clearly that was not like an actual photograph of Michigan. What if I want to use an actual photograph? Well, if I can get a TIFF file that is from a photograph, let's say a satellite or from an aerial photograph, I can proceed. Now, this is the part of Hadley's code that I couldn't get to work on my machine. I am going to go ahead and use 2 data sets from Hadley's website and proceed to complete this video. But I attempted to pull data from all of these, and it didn't work out for me. All right, so all of these are from this geostationary satellite operated by the Japan's Meteorological Agency. And it takes images across 13 distinct bands. And the ones that we're going to be looking at are going to have 3 bands each. All right, so let's go ahead and load the data. All right, so here I downloaded the data from Hadley's website. You can see that it's in a TIFF file. I'm going to use the stars package, and I'm going to read stars. So this is like the R stands for raster. Now, what's going to happen if I just grab this and I put it in the stars? There's going to be a lot of information in this particular image. There's a lot of stuff going on. And what's going to happen is the amount of information on there is going to overwhelm my machine. So to make sure that I'm able to plot this, that it's not going to kill the memory of my machine, I'm going to make the image a little bit more coarse, which will be fine for my purpose. And so this part of the code just takes the information that I have from the photograph, makes it a little bit more coarse, and so that way there's less memory required to work with this image. And so that is IDE 00421, and this is IDE 00422. All right, so this one is, let's see, IR, grayscale, like that. And this one is VIS, grayscale, like that. All right, so we're going to be plotting these 2 data sets. And if you go and you download the data, this part tells you when the images were taken. So this is the year, this is the month, this is the day, this is the hour and minutes. All right, so I know exactly when this image was taken. All right, and so here we can see some information about the first data set that we're going to work with. We've got 3 dimensions and 1 attribute. And we can see that we have X and Y coordinates here. And we have 3 different bands. And here's some information specific to mapping raster files. And we see similar information for this one. All right, so now let's go ahead and let's just go through and let's plot a real quick and easy one. So what I'm going to do is I'm going to take this, I'm just going to pass my data to geom stars from the stars package. Remember, I'm dealing with coordinate data, so I don't want to fill up the plot region. I want it to keep the aspect ratio at 1. And so I put coordinates equal, and then I hit it with ggplot. All right, so here we can see that it picked a value for us to be blue scale by default. All right. And we see something very similar for the other data set. And we can see that the plot, approximately half of the area that the satellite was facing was in nighttime at the time of the image. Kind of interesting to see. All right, so now let's go ahead and let's take those bands, and and we've got a range. The bands have a range of values from 0 to 255. Notice it goes from 0 to 255 up here. And what I want to do, I want to plot each of the 3 bands of this. So just to do that, to make it nice and easy, I'm going to go ahead and use faucet wrap. So what this does, this makes 3 different subplots. And just to convert band to a format that I can work with, I put var as band. And then I'm converting to grayscale, just so that it's a little bit more familiar as I look at it. And so here we can see what's going on. All right. Let's do the same thing again, but this time we've got, half the Earth is dark. All right, so now let's go ahead and let's start doing stuff that's more interesting for data science. I want to go and I want to take some data and I want to overlay it on top of the map. That way this becomes more informative. Okay, so what I'm going to do, I'm going to get the political boundaries of Australia. And then I'm going to put that on top. Now there's a problem with this. As is, I can't just jump at it. I need to make sure that I have a common coordinate system for everything I'm working with, or this isn't going to make sense. It's very important that I have consistent coordinate systems when I do my plotting. So how I'm going to handle this is I load the data from OzMaps. Then I'm going to do a transformation on the SF file. So I specify the data set, and now I specify the coordinate system. And I say, go and extract the coordinate system from that first data set that I was looking at. Okay. And so now when I go to overlay, all I have to do is, well, I do the same thing I did with the previous plots before faucet wrap. Now I put geom SF. My data is Oz states, but remember, I've modified the coordinate system. I don't want to do any filling. And I'm just going to put white boundaries around each political region. Remember, I need to do something to make sure that I have an aspect ratio of 1 when I do this type of plotting. And I don't want any background. I don't want any grid background back there. So theme void will get rid of all that junk for me. And I'm using grayscale. All right, so now let's take a look. So now it's much easier to tell where is Australia on the map? Before I really couldn't tell where anything was. Now it's pretty clear. We can do the same. And so we can see that the western part of Australia was at night when this image was taken. So let's kick it up a notch. Let's put even more data on there. All right, so let's go ahead and put the political region capitals onto there. So I've got a data set. And here's my latitude and longitude. I'm going to take my capitals, and then I'm going to set it up so that I have the coordinate system I want. So my coordinate system is going to be 4326, a very standard one. And I'm going to call that new data set, where I take this and I specify the coordinate system. I'm going to call it new data set cities. Now, just to make sure I get everything right, I go ahead and I use a transformation. So the previous step, I set it up so that my data had a coordinate system. So here I set up so that I have a coordinate system at this point, but I'm not 100% sure if that's right. I want to make sure that I have robust code. I want everything to match up. So what I'm going to do, I'm just going to go ahead and declare that I want cities to have the coordinate system for IDE 00421. Now, I don't know what that coordinate system was, and frankly, I don't care for this purpose. I just want everything to match up. So I go ahead and just do the transformation. Now I'm ready to start doing some ggplot. So once again, I'm going to use geom_stars to plot the raster image. Then we take the simple format data and plot it. Now I'm going to go one step further, and I'm going to go ahead and put the cities in red. I make sure that I have everything in the aspect ratio of 1. Get rid of the grid and the background and the axes and all that. I'm putting it on grayscale, and boom, I've got a nice image so I can see what's going on. So you can see someone going through this process and doing exactly this for like weather. You see similar maps every morning on the news. And I can do the same thing for the other one. And so it's much clearer and it's much easier to see what's going on when I overlay critical information. Now I can take it a step further, and I can specify that I want to label the cities. That way it's easier to see. Now, there's an overlap problem, but I didn't feel like dealing with it when I was working on this. And here it is again. All right, so that's all I've got for you. Take care and goodbye.